Hi, I want you to take a look at this. Here is a video of me sitting in front of my camera. It's a color-graded 12-bit B-roll file opened in DaVinci Resolve on Arch Linux. It looks okay, colors are decent, but if I decide to take a screenshot or extract a PNG file and then open it in the Eye of GNOME, default GNOME image viewer, it'll look slightly different. Something is off. My skin looks weird and overall image feels less saturated. By the way, to show you this, I'm capturing my screen with OBS, and if I open the screencast in VLC Media Player, it'll look different again. Way too contrasty. Well, perhaps something is wrong with VLC, maybe I shouldn't trust my software, maybe I should upload video to YouTube and oh, different browsers render image differently too. Okay, it is time to talk about color management on Linux. Color management is an umbrella term that covers things like software profiling, hardware calibration, and embedding color profiles into images. The goal of color management is, of course, to ensure consistent and accurate color reproduction across various devices. It doesn't matter what you are doing, photo editing, filmmaking, UI and visual design, you want to have precise control over your image. The whole process of color management relies on ICC profiles, binary files that contain all required data to display colors consistently between different devices. Each device is capable of handling a different range of colors. If you post your content online, you may want to make sure that your colors look decent even on cheapest monitors by switching to sRGB. And if you are planning to print your own stuff, you need to be able to preview your image in CMYK for the best results. So the main purpose of the ICC profiles is to translate colors between different devices, be it a monitor, a scanner or a printer. To achieve maximum accuracy and great color reproduction, you may want to do both. Calibrate your monitor and select a set of color profiles to see how your image may look like in different scenarios. Gladly, we have some great free software such as DisplayCal, which has a native package for almost any major Linux distro. ArchWiki has a ton of useful information in regard to hardware-assisted calibration, and I strongly recommend you checking it in case if you want to calibrate your own monitor or a printer or a scanner. If your hardware calibration device doesn't support Linux, you can still generate color profiles on different systems. Thanks to the open specification, ICC color profiles are compatible with all modern operating systems. So if a certain .icm file was created on Windows, it'll work on Linux as well. You can even try using some ICC profiles available on the internet. For example, ratings.com testing lab always provides a calibrated binary file in each display review. Though I must warn you that they don't recommend loading their ICC profiles on another monitor, even if you have an identical model. That's because you may get slightly different results due to a certain level of manufacturing tolerances. If you find this video helpful, please consider joining channel membership with special perks. You can also make a single donation by hitting thanks button underneath the video. I keep my videos completely free from paid promotions, product placements and sponsorships. I respect my audience and I need your help to keep it this way. Some desktop environments, like GNOME, have their own straightforward color profile tools, accessible via Control Panel. Both KDE and GNOME rely on the service known as ColorD, and others have to use xiccd as a bridge between ColorD and X. Note that the problem that I demonstrated in the beginning of this video is not a problem of hardware calibration. In fact, it is not a problem at all. It's a result of color profiling, default settings, and standardization. Let's break it down. If an image has no ICC profile embedded, which is exactly the case with all PNG files, Eye of GNOME will automatically assume that it should be displayed in sRGB. And since sRGB color gamut does not use full range of the Adobe RGB, it'll inevitably look less vivid. In fact, the further your display color gamut is from the sRGB standard, the more difference you'll be able to perceive. And if I switch my display profile to sRGB, there will be no noticeable difference between the image that I see on my screen and the screenshot itself. See? They are exactly the same. Of course, I don't recommend narrowing your display capabilities to a relatively small color gamut, but you definitely should be aware of how your system works and why certain applications display colors differently. According to the World Wide Web Consortium, all untagged paged elements, including images, should be displayed as sRGB, and Firefox by default doesn't follow this rule and handle colors a bit differently. That is also why videos on YouTube, while opened in different browsers, may look a bit different. Since Linux color management workflow relies on the same standardized ICC profiles as macOS and Windows, it is safe to say that it is functional. I edit all my photos and videos on Linux, and I'm happy how consistent and accurate my results are. But Linux still lacks some quality of life improvements. According to the Arch Wiki, Wayland supports color management through color profiles, but the user interface suitable for managing these profiles is currently not implemented properly. There is no 10-bit color support on Linux, and HDR support is experimental, to say the least. GIMP still lacks full CMYK color model support, and keep in mind that proprietary applications running under Wine may produce some weird bugs. Despite all of that, I'm genuinely happy with the current state of color management on Linux, and comparing this to what we had like 10 or 15 years ago is mind-blowing. With every year, Linux gets only better and better. This was Reluctant Anarchist, and I have nothing left to say.